The Materials World modules are hands-on, inquiry and design-based curriculum units for middle and high school students. Using principles from the interdisciplinary fields of materials science and nanotechnology, this curriculum aligns well with STEM objectives, engages students, and adds relevance to existing curriculum.
Hi, I'm Ken Turner, and I teach chemistry at Schaumburg High School. I'd like to tell you a little bit about the Smart Sensors module from Northwestern University. It's a great set of activities that you can put into almost any classroom. It's all about a fantastic plastic. This plastic is really remarkable. It's in all sorts of devices already. The remarkable thing to me is that when you touch it, it produces a voltage that you could measure on a voltmeter. This particular plastic, the way you understand it is to study the chemistry of its composition. The way to understand how it produces a voltage is to understand its composition. The way to understand how you'll use that voltage is to understand concepts like current and voltage and amps. But you can't start the students out with that. You have to start them off with something that's going to get them interested in this thing. The way I get my students interested is I bring out a motion detector. Now, bring out a motion detector or two and tell the students they have to evade that motion detector. Divide the class into teams, one team for every motion detector, and tell them they have to evade it. They're going to walk, they're going to run, they're going to skip, they're going to roll, they're going to use mirrors, they're going to ask to have the lights off. They're going to be doing science. They're going to be asking questions about how it works. What is it sensing? And they're going to be out of their seats, engaged in the inquiry at hand. It's going to be terrific. And they are going to be probably more involved in your science class than they have been in a while. When they start to figure it out, you can bring in other activities. When they start to decide how this particular device is measuring, their motion, then you can bring in other materials. You can bring in toys. This particular toy responds to sounds. It's responding right now to my voice. There's all sorts of toys that you can bring into the classroom and set them up in stations. The students will go from station to station trying to figure out, what is it sensing? What is it sensitive to? What is it reacting? How is it reacting? What is the material doing that sensing? It's another way to get the students asking the questions, posing those inquiry-laden questions, and trying to figure out how to answer them, because the means to answer those questions is right there where they can manipulate it, where they can use it. They're going to find out that this plastic, besides running a motion detector, besides running these toys, you can use things as simple as a balloon and a cup and a couple of leads. To make a microphone. There's the plastic right there. When you turn this microphone on, just by tapping on the surface, they'll get it. They can hear the sound, and they can talk across it. They can sing across it. They can devise their own experiments. They can see whose microphone works the best. You can use this same plastic, hook it up to a radio, and it'll play. You'll hear it. It's being used as a speaker now. It's just an extraordinary material. Once they get these interesting things done, they're still asking these questions. How does it do it? What is it that allows this plastic to do this stuff? And it's all in how the plastic is put together. So I'm going to put a model together. The plastic is all put together based on a monomer like this, a small molecule. If you take a couple of these smaller molecules, break those double bonds, you can put them together and make the molecule longer. So you get a longer chain. Now this is just two of those small molecules. You'd put together hundreds, thousands, tens of thousands. You'd have a huge long chain. You can use these model kits, you can use these right in the classroom, but of course you wouldn't use tens of thousands of them. When you have the student teams build a big molecule, it'll probably be mostly jumbled, which is very accurate. That's how the polymer is made. But the polymer doesn't work that way. The polymer works when you introduce order. So they pull the molecule, and you can pull the model. And they electrically pull it. They put electrical field across it. And they introduce greater and greater amounts of order into this polymer till you have a very ordered polymer. This ordered polymer, the more order it has, the better it does its job. The more voltage it will produce per flick of your fingertip, or per temperature change, or per pressure, or per anything. It works better when it's ordered. This is the kind of chemistry and physics you can teach when you use the Smart Sensors module. It's going to be great. Your kids are going to love it. They're going to be involved in inquiry. They're going to be asking questions. They're going to be manipulating. You're going to love your classroom. They're going to love your class.